Good afternoon, everyone. My name is Bongile Twala, and I'm coming live to you from Sci-Bono Discovery Center in Newtown, Johannesburg. And today we are going to talk about pressure. Not peer pressure, but pressure that is a force over a given area. Now, this actually has a formula to it. And this formula speaks to itself. It is pressure equals to force over area. That means pressure is directly proportional to the force. When you increase the force, you increase the pressure. And also if you decrease the force, you also decrease the pressure. However, pressure is inversely proportional to the area. That means when we increase the area, when you have a big surface area, you will have less pressure. However, when you have small surface area, you will have more pressure. Now, how can we put this into practice? Now, in front of me, I have two blocks. Now, these blocks have nails. One has 64 nails and the other has only one nail. Just by looking at things, we can tell that the block that has 64 nails has a bigger surface area than the one that has one. And for our experiment, we are going to be using a blown up balloon. I know from where you're seated, you are thinking a blown up balloon and nails should not come together. But now this is going to help us understand pressure equals to force over area. Now, the next thing I'm going to do is place the balloon onto the nails and apply a force. Now, a force is either a push or a pull. In this case, we are going to be pushing. Now, you can guess what will happen to the balloon. I expect to hear something. But let's see what will happen in 3, 2, 1. Okay, let's try that again. 3, 2, 1, push. I was expecting to hear something, but nothing happened. Now, usually, if a balloon that is blown up comes in contact with the nail, it is supposed to pop. But now, in this case, it did not. Let's see what will happen with the one nail. Now, I'm going to do the same thing. I'm going to place our balloon on top of the nail and apply a force. Once again, guess what will happen to the balloon? But let's see in a countdown from 3, 2, 1. And the balloon popped. All right. Now, guys, you wouldn't want to try this at home because we are using nails and nails are dangerous. Now I'm going to show you a way of doing the same experiment by using things that are safer. And for this experiment, you are only going to use your hand and your forehead. Make sure there is nothing on your forehead. But before you attempt to touch your face, you need to make sure you wash your hands for 20 seconds using soap and water. But I am going to be using a sanitizer. You can use that as well. As you know, we are still facing coronavirus, all right? Now that our hands are nice and clean, we can try out this experiment. So you're going to have your hand out like this, and you are going to place your hand onto your forehead and apply a force. Or you are going to push against your forehead. So let's all place our hand onto our forehead, and I'm going to count you down to push against your forehead in 3, 2, 1, push, push harder, and stop. Now, you did feel a force. You did feel your hand pushing against your forehead. But now your hand has a big surface area. Now we're going to decrease the surface area by using your thumb. So you're going to do the same thing. You're going to place your thumb onto your forehead and apply a force or push against your forehead in 3, 2, 1. Push, push harder, and stop. Now, that was uncomfortable. And it actually felt different from when you were using the palm of your hand. And this is why. Now, the palm of your hand, when your hand is like this, it has a big surface area, just like the bed of nails that has 64 nails. So when we were pushing the balloon onto the nails, the force that we were applying was actually evenly distributed on the nails and the balloon. And that's why the balloon did not pop. However, when it comes to your thumb, the reason why that felt uncomfortable is because you were experiencing more pressure. Same as when we were pushing onto the balloon, when we were pushing it onto the nail, all the force was actually focused onto one point, the nail. And that is why the nail was able to penetrate the balloon and make it pop. Now we are going to look at the weight of the atmosphere, and we also call this atmospheric pressure. And to test this out, we are going to need normal tap water, which right now is at room temperature. We are also going to need about 10 milliliters of water and a can. Now this can right here is open. You might assume there is nothing inside, but there's something. There is air. And this air at this point is at the same temperature as the air outside the can. Also, it is moving at the same speed as the air outside. Now, since we're talking about atmospheric pressure, this is actually the weight of the air that we have all around us. We cannot see this, we cannot feel this, but it's pushing against every single thing. Now guys, I am going to heat up the inside of the can, and to do that, I am going to be using this fancy equipment called a Bunsen burner, all right? Now a Bunsen burner has a flammable liquid inside, and if I release that liquid and it mixes with the oxygen and we introduce a flame, we are able to get a fire. Now I'm going to use this to actually boil this water as I am pouring it into the can, all right? Now guys, if you don't have a Bunsen burner at home, you can actually use a stove top. However, make sure that you are using minimum heat, all right? Also, as you can see, I am not holding the can with my bare hands because the can is going to get hot eventually. So I don't want to burn myself. Now make sure you have tongs that will help you hold the can. And once again, when we are trying out these experiments, we need to make sure that we are safe, and that is why I'm wearing my goggles and my lab coat. You can actually wear an apron when you are at home. And also make sure you do this with an adult. Now what am I doing here? I'm actually heating up the water. I'm doing the same thing that you do at home when you boil water. You get to see bubbles, and eventually you start seeing water vapor coming out. And that is the same thing that is happening here. So I'm heating up the water, changing it from a liquid to a vapor. And eventually, as you can see, there is water vapor coming out. But now guys, I am going to invert our can, which has hot steam inside, and I'm going to invert it into the cold water. Now obviously, this steam is going to cool down. And let's see what will happen in 3, 2, 1. And the can implodes. Now how did that happen? Now remember, I told you that the air that we have all around us is pushing against everything, and we call that atmospheric pressure. Now what happened here is when I changed the water into steam, the steam particles were moving around very quickly, and they were exerting pressure in the insides of the container. But once I cooled them down, they quickly came together, became sluggish, and they changed back to water. Now at this point, they are unable to exert pressure on the insides of the container. But now in nature, we always like things to be balanced out. We cannot have a high pressure and low pressure. Now since these particles were not able to exert pressure onto the walls, we were having a low pressure inside the can. But now, since I inverted the can and closed the opening of the can, the air outside, since it wanted to rush in, it couldn't. So therefore, it actually crushed the can. All right. Now we are going to move on to another experiment on pressure. And this experiment actually involves a flask, which is clear. You can see what is inside. And at this point, we can say that there's only air inside the flask. The air is at the same temperature as the air outside, and it is also moving at the same speed. Now, what I'm trying to do with this experiment is try to get this balloon, which has water inside, into the flask without forcing it or even popping it. Now, as you can see, when I place the balloon, it does not go in. Even when I try to push it in, it does not go in. But now what can I do? I can try to do the same thing that I did to the can by actually introducing a high temperature, all right? And to do that, I am going to use this piece of paper. I'm going to light it up, all right? Now I'm gonna have to make sure that it catches fire. And as it catches fire, I'm going to chuck it into the container, and the balloon goes in easily, just like that. And this is with all the help that we are getting from atmospheric pressure, all right? So what actually happened there? When I heated up the piece of paper and I throw the paper inside the container, that fire was able to heat up the air particles. Now, when it heats up the air particles, they get to move very quickly and they exert pressure in the insides of the container and also the balloon that is on top. But the moment the fire goes out, these air particles actually start coming together. And as they come together, they are no longer able to exert pressure. And therefore, the high pressure that we get from the outside will actually squash the balloon. This is in turn the air trying to go into the container to balance things out. And this is how our vacuum cleaners at home work. When you plug your vacuum cleaner onto the socket, you start hearing a very loud sound, and that is coming from a fan at the back that is driving air out of the vacuum cleaner. As it drives air out of the vacuum cleaner, you get low pressure inside. But now, since there's high pressure outside, the high pressure will start going into the into the vacuum cleaner. As it goes into the vacuum cleaner, it takes dirt together with it, all right? Now, guys, we are going to look at pressure chemically. We were looking at pressure in terms of physics, but now we're going to look at it chemically. Now, for our next experiment, we are going to be using something that you can find at home, and it is dangerous. What I have here is methylated spirits. Now, methylated spirits is actually a mixture of ethanol and methanol. Now, this is very, very flammable, but it's flammable when it becomes vapor and it mixes with oxygen in the air. Also, another fact about this is that it can change from being a liquid to a vapor at low temperatures. We need about 12 degrees Celsius for this to start changing from a liquid into a vapor. Now, here I have another can, and it's open. You might assume there's nothing inside, but there's actually air which has oxygen. Now, I am going to pour our methylated spirits into the can, but another thing that we have here is we have two holes. There's actually a big hole at the top, and I also have a very tiny hole on the side. Now, this hole is going to help us to be able to ignite the mixture that we're going to create inside the can, all right? So, guys, I don't need the liquid. I just need the vapor of the methylated spirits. So I am going to get rid of the liquid. Before I get rid of the liquid, I should shake this up a bit and slowly change the methylated spirits into a liquid. Now let's get rid of the liquid, and all we are left with is methylated spirits vapor and air inside the can. Now, when you attempt this, guys, since we are dealing with a flammable substance, you need to make sure that you don't have any methylated spirits on the table. So therefore, get a cloth or toilet paper and wipe your table. And before you attempt this, make sure you remove the methylated spirits from where you are doing your experiment, all right? Now, guys, as I said, we have the dangerous mixture inside now, and all we have to do now is ignite it. So I'm going to close the top of the container, and I'm going to use a flame to light up the mixture. And as you can see, I'm using a long stick. You should be at least 1 meter away from the can. Now, let's see what will happen in 3, 2, 1. And that popped. All right. So what actually happened inside here? So when I poured the methylated spirits into the can, it was a liquid. But as I shook up the can, that liquid changed into a vapor. Now, these vaporous particles will actually start moving around inside the can, and they will start mixing with the oxygen. However, I introduced a flame to the mixture. As I introduce a flame and ignite the mixture of the vapor and the air, I was able to get hot gases. Now, these hot gases move even faster than the methylated spirits vapor particles that we had before. So as they move faster, because we have closed the can, we're able to build up pressure there. So as we build up pressure, these gas particles will actually try to shoot out. As they shoot out, they push our cup up. All right. Now, guys, that is all from me and Sci-Bono today. Please make sure that you follow us on our social media platforms, Facebook, Instagram, and Twitter, to see more of these. However, please make sure, if you want to try these out, that you are safe. Make sure you're trying it next to an adult. Don't try this anywhere without adult supervision. Now, from me and Sci-Bono, I hope that I will see you next time. Goodbye.